morning, Miss Yu and teachers. I am Brighton Wong, register number 16.
I am Ernie Yip, register number 7.
And I am Wesley Wong, register number 26. Today we will be investigating the effects of acid rain on Taj Mahal and Colosseum.
Some background information about Taj Mahal. It is located in Agra, India, which has an average temperature of 40 degrees Celsius. Due to many industries and factories around the area, the air quality is poor. Thus, there will be a higher concentration of acid rain there. It also has a large surface area of 17 hectares.
As for Colosseum, it is located in Italy, which has an average temperature of 25 degrees Celsius. The area around it mainly consists of shops instead of factories, leading to a better air quality. Thus, the concentration of acid found in the rain there is lower. It also has a smaller surface area of 2 hectares.
To sum it up, Taj Mahal has high temperatures, high concentration of acid found in the rain and a large surface area, whereby Colosseum has relatively low temperatures, low concentration of acid found in the rain and a smaller surface area. Moving on to our mole calculations. We have assumed that 100% by mass of the eggshells is calcium carbonate. Assuming every eggshell weighs 5 grams, the number of moles of the calcium carbonate in eggshells will be 5 grams divided by 100.1 molar mass, which is 0.0500. Based on the equations 2CH3COOH plus CaCO3, which is converted into CH3COO2Ca plus H2O plus CO2, for every 1 ml of vinegar, 0.0417 gram of eggshell is required to balance the equation. Hence, 120 ml of vinegar is required to dissolve an eggshell, which is assumed to weigh 5 grams.
For the experiment on how temperature affects the rate of reaction in calcium carbonate, I have stated some independent, dependent, and constant variables as shown in the slide. One important point to note is that due to the different chickens the eggshells come from, we have crushed the required eggshells beforehand and mixed them together before measuring the needed amount. This ensures that all the different eggshells will be used in the experiment, thus ensuring a fair test. Moving on to the procedures, 2 samples of 5 grams of eggshells are measured, as well as 120 ml of vinegar. The vinegar is then poured into a water bath of 40 degrees Celsius as well as 25 degrees Celsius, representing the temperature of Taj Mahal and the Colosseum respectively. The temperature of the vinegar is measured using a thermometer, and once the temperature is correct, the eggshells will be poured into the vinegar. The stopwatch is started once the eggshells are poured into the vinegar, and the experiment will last for 10 minutes. As for the results, it is apparent that the heated vinegar, which has reacted with calcium carbonate, lost more mass compared to the chilled vinegar, since carbon dioxide was formed quicker due to effective collisions. The rate of reaction is also much faster. This occurs because as the temperature increases, the CH3COO- molecules and the H plus ions in the vinegar has more kinetic energy and moves faster. This increases the chance of H plus ions colliding with the CO3- molecules, therefore increasing the chances of effective collision. As effective collision occurs, the reaction reacts to become carbon dioxide and water, and since more carbon dioxide is given out, the mass will also decrease faster. Similarly, if the temperature is low, the effective collisions that occur will be less, thus producing less carbon dioxide, and there will be a lesser decrease in mass. Thus, the decrease in mass for a higher temperature is significantly higher and faster compared to that of a lower temperature, since there are more effective collisions and carbon dioxide loss.
Next, I will be investigating if the area of exposed surface will affect the rate of corrosion. This is done so by the experiment that I am about to show you. Firstly, these are the independent, dependent, and constant variables. Here is an estimated and approximated calculation of the exposed surface area of both Taj Mahal and the limestones. Since the Taj Mahal has a bigger exposed surface area, it is expected to corrode first. Step 1 is to measure 5 grams of eggshell for the experiment for the crushed eggshell. The second step is to measure 120 ml of vinegar and pour the vinegar and eggshells together into a 100 cm3 conical flask. Lastly, put the rubber stopper on the conical flask and connect the delivery tube into the beaker through the beehive stand. Then record the initial volume of beaker and record the volume every subsequent minute. Repeat steps 1 to 4 for the uncrushed eggshell. This is the data I've collected. As you can see, the results for the change in volume for the uncrushed eggshells remained mostly consistent, with a change in 2 cm3 volume every minute. By the end of 6 minutes, there was a change of 10 cm3 of water. As for the results for crushed eggshells, the change in volume was also mostly consistent, having a change of 6 cm3 every minute. At the end of 6 minutes, there was a change of 34 cm. The amount of volume changed is due to the amount of reaction between the eggshells and vinegar. Thus, the crushed eggshells corroded faster due to their higher exposed surface area. Now I'll explain using collision theory why there will be a higher rate of corrosion with increasing exposed surface area. Chemical reaction only occurs when particles of reactant collide and there is enough activation energy and appropriate collision orientation. Since ethanol acid in vinegar is weak, it dissociates into H plus and CH3COO- particles. However, not all collisions are successful. If there are successful collisions, 2 H plus ions will react with CO32- ions to form H2O or CO2. Increasing the surface area of solid reactant exposes more of its particles to the other particles to react. This results in an increased chance of collisions between the reactant particles, so there will be more successful collisions and faster reaction rate.
Moving on to the experiment determining whether the concentration of the acid in the wind affects the rate of corrosion of limestone structures. Firstly, measure 5 grams of eggshells and 120 ml of vinegar. Then put the beakers of eggshell on a weighing scale before pouring vinegar into the beaker. Lastly, observe and measure the weight loss of eggshells after 7 minutes. Repeat the experiment 3 times, but with the vinegar heated for 20, then 40, then 60 seconds before cooling the vinegar to room temperature before proceeding on with the experiment. At the end of the experiment, the results show that when vinegar is heated longer, the rate of dissolving eggshells is faster, which proves the hypothesis that a higher concentration of vinegar will dissolve eggshells faster. Now I would use the corrosion theory to explain why this happens. At a normal concentration of vinegar, due to its low concentration of 5%, there is very less molecules of acetic acid in 120 ml of vinegar, while the other molecules of vinegar is water. When the vinegar is added to the beaker of eggshells, due to a low amount of CH3COOH molecules, only a small amount of calcium 2+ ions from calcium carbonate will react with acetic acid, and hence the rate of dissolving eggshells is lower. However, at a higher concentration of vinegar, for example 15%, there will be more molecules of acetic acid found in the same volume of vinegar. When this concentrated vinegar is added to the beaker of eggshells, since there are more CH3COOH molecules, there will be a higher amount of calcium 2+ ions reacting with the acetic acid, and hence the rate of dissolving eggshells is faster.
Since our results show that a larger surface area, higher temperature, and higher concentration of acid reacts with calcium carbonate faster, we conclude that Taj Mahal will corrode faster.